Ja, es gibt in unserer Branche Hidden Heroes, verborgene Helden, über die wir nicht unmittelbar und dauernd erfahren. Und dieser Gentleman hier ist ein solcher Held, der mitgeholfen hat, dass ein Teilverbot einiger Neonicotinoide in Europa realisiert wurde. Ich freue mich sehr über Jean-Marc Bonmatin.
Thank you.
Please stand here.
Yeah. Hello everybody. Guten Morgen. My name is Jean-Marc Bonmatin. Bonmatin means in French, Guten Morgen. So it's easy to translate. I am very happy to be here today, and I would like to thank the organizers, and especially Jürgen, for this invitation and for giving me the opportunity to speak to you about a difficult subject, pesticides. So my presentation today will deal with pesticides and particularly insecticides which act on the central nervous system of bees, but not only on bees. And you will see in my talk that what kills the bees have effects on our health. So on the first slide, I choose to present a ladybug on a leaf. And if the plants are treated with insecticides, and especially with imidacloprid, remember this name because I will take this chemical as the archetypical insecticide, this ladybug will be exposed to imidacloprid, to this toxicant. And of course, bees, you will see, are also exposed to these chemicals. So, just to give an overview of the problem, you should know that biodiversity on this planet is mostly represented by insects. If you are a Martian coming from space, the living organism you will see on the planet is insects first, with about 2 million of species here. And after that, you will see plants with only 2,000 species, 200,000 species. Then fungi, then this unicellular organism, crustacean, worms, fishes, only about 10,000 species of birds, then reptiles, amphibians, and mammals. Only about 5,000 species. Okay? So keep in mind that what is on the Earth about living systems and ecosystems are insects. And about insects, I have the data for France, but it's almost the same thing in Germany. You will find 4 main families of insects: Diptera, flies, arachnids, Coleoptera, and Hymenoptera. And bees are belonging to this family. So they represent about more than 1,000, 2,000 species, because there is wild bees and honeybees, of course. And about biodiversity, in 2016, an international platform, an international governmental platform representing more than 150 countries, stated that there is a problem. Pollinators are facing extinction, and particularly vertebrate pollinators, such as some birds or bats, but more importantly, 40% of insect pollinators, mainly butterflies and bees, that are facing extinction on the planet. This is a real problem. You know that if there is no bees, there is no pollination. And if there is no pollination, there is no food production. Okay? So this platform said that various factors are affecting pollinators, and among these factors, one of the main factors are pesticides. And they were very brave because they dare to cite one particular class of pesticides, the neonicotinoid class. It is difficult to pronounce for the translator, neonicotinoid, but I will present them to you. So, including neonicotinoids, insecticides. So I am going to speak about that today. And of course, they gave numerous options to safeguard pollinators, and one of the first options was to decrease exposure of pollinators to pesticides in general and to these insecticides in particular. So, what are they? So, sometimes you have some words in German for you to understand better. So, neonicotinoids, they are insecticides acting on the central nervous system of insects, of course, but not only on insects, on everything. So in the brain, you have neurons, and each neuron is connecting to other neurons. And at this connection here, you have chemical messages. Usually these chemical messages are called acetylcholine. With new insecticides here, this is the family of neonicotinoids. These insecticides, they act at the level of postsynaptic, at the postsynaptic level. They replace the neurotransmitter acetylcholine, and they excite neurons. And particularly, they take the place of acetylcholine here. They open this sodium channel, creating an excitation of muscles, for instance. And the insect, the target insect, is going to die by a general cramp, okay, because muscles are contracted, and this in probably some milliseconds to seconds, depending on the size of the insect. And all these insecticides have been used for different options. So you have here, in the family of neonicotinoids, you have imidacloprid here. This is a small molecule, in fact, easy to synthesize. And it has been used as a go-show formulation for cereals, for instance, but also as a formulation called confidor in France. This is for fruit trees. Premise, this is a formulation to treat wood stock. And also advantage, which is a formulation to treat pets against fleas and ticks. So you understand now that these chemicals are not specific to aphids, for example. They can kill termites or fleas or ticks, all insects. Understanding that, you will understand that the effects of neonicotinoids are not only targeted on pest insects, but have a wider range of effects. How do they are used? You can treat crops by two ways with systemic insecticides. by spray or by seed dressing. Spray, you know that by heart. And when you spray a field with this kind of insecticide, you use about 500 grams per hectare, because most of the toxicant is going in the atmosphere. Using seed dressing, the quantities are quite less, about 100 grams per hectare. How does it work? In fact, the chemical is dressing the seeds here. You have undressed seeds here in yellow and dressed seeds in red. And the toxicant is around the seed. Then the seed is in the ground during sowing. Then the chemical diffuses in the water contained in the soil. It is taken up by the plant, by the sap, and the chemical is distributed in every part of the plant because it is transported by the sap, so that the plant is protected against sucking insects, for instance, during all its life, from sowing to the harvest. The problem is that because the toxicant, the chemical, is everywhere in the plant, it is also in flowers. It is also in flowers, it is in pollen, it is in nectar. So now let's have a look to the hypotheses which have been used to register these insecticides in every country. And in fact, I will demonstrate to you that all these hypotheses were false. And especially when we speak about exposure and toxicity. So let's have a look and compare a little bit some chemicals that are used in crop production. This is a complicated table, but I am going to speak about only 2 lines. So this is acute toxicity for honeybees of all these chemicals. And you can see here on this line DDT, which is well known and which has been banned for years, and imidacloprid, which is the main representative of neonicotinoids. And in fact, if you compare the doses in grams per hectare, you will see that going from DDT to imidacloprid, there is about a factor of 5 or 6 less imidacloprid used in field than was the DDT. If now you compare the toxicity of imidacloprid to the one of DDT, this is expressed by the lethal dose 50, means the dose that kills 50% of bees, expressed in nanogram per bee. Nanogram is 10 to the minus 9, okay? So for DDT, the data shows 27,000 nanogram per bee to kill half of the population of bees. But for imidacloprid, it is only 3.7. Means that if you make the ratio of toxicity between imidacloprid and DDT, you will find a ratio, of course, of 1 for DDT and 7,000, about 7,300 times. Means that imidacloprid is more than 7,000 times more toxic to bees than was DDT. So less amount by a factor of 5 or 6, but an increase in toxicity by a huge factor. Okay? So when speaking about bee health, it's not a good deal. And now I am going to show you what happens when giving this imidacloprid to bees. During the registration process, what is looked at is the short time toxicity, means 1 day or 2 days. If you expose bees 1 day or 2 days with imidacloprid, you have the corrected mortality here in percent and the time here. There is nothing. No bees are dying. But if you continue the experiment, then you will see something happening. And this was not taken into account during registration. What happens? First, you can see that you can reach high mortality in just 8 days. And this occurs at 10 nanograms of toxicant per gram of food. And the curve is almost the same at 1 nanogram of toxicant in 1 gram of food. This is a first information. The effects does not depend on the dose. You can divide the dose by 10, you still have the same effect, about 60% of mortality. The second thing to remember is that if you still continue to dilute the dose, you go here at 0.1 nanogram of toxicant per gram of food. This is nectar, in fact, which is contaminated. And you still have an effect here, about 50%, 30% of mortality. You still have an effect, even you lower and lower the dose. And this dose is very, very small. So, during registration, you should take care of mortality, not on the first day or the second day, but along at least 1 week. And when you do that, you see some effects. You don't want to go further? Thank you. So, what are these very small doses? For a chemist like me, this is really a difficulty. This is a challenge, because 1 nanogram of imidacloprid per gram of pollen, for instance, when you want to analyze it, this means this quantity, okay? And it's difficult to imagine. So let's go at our scale. 1.1 nanogram of toxicant per gram at our scale represents the equivalent of the mass of 1 cent as compared to the mass of the Eiffel Tower. There is exactly the same ratio, okay? So for a chemist, this means that we should be able to detect a variation of mass, which is the equivalent of this piece on the Eiffel Tower. This is a difficult challenge, but we did it. So some people say, wow, this is very, very, very small amount. That doesn't count, in fact. But for B, the same quantity represents 234 billions of molecules of imidacloprid contained in a brain. Okay? This is the number of neurons that are affected by the chemical when you treat with this dose. So this is a huge dose for a bee brain. Let's go to the result. We made some analytics on pollen and nectar. This was in 2003, 20 years ago. And we already know that there was a lot of quantities of imidacloprid contained in soil, in plants, in nectar, in pollen. And I can give you, this is the original paper, okay? So I show always the original paper demonstrating something. So with this technique, we were able to analyze especially pollen and nectar to see how bees were exposed during foraging. And I can give you the result. When you look worldwide, you see that the average contamination in pollen is at about 20 nanograms per gram, and the average contamination of nectar is higher at 73 nanograms per gram. Of course, this depends on countries, this depends on crops, this depends on agricultural practices, but on an average level, you have this contamination. If you compare this data to the doses that affects honeybee health, and especially mortality, you will understand that there is too much imidacloprid in fields, and that probably these chemicals have effects on bee health. Of course, remember, it was 0.1 nanogram per gram, and we have in fields 20 and 73 nanogram per gram. This means bigger quantity by a factor of at least 2,000. Now, there is direct effects of such insecticides on bees, but there is also effects on bee health. And you have a publication here made by Italian people that shows you that the indirect effect of these chemicals act on the ability of bees to defend against viruses. And in this publication, they demonstrate that neonicotinoid insecticides, it was true for clothianidin and also for imidacloprid, they lower the immune defenses of bees, so that replication of DWV, this is a deformed wing virus, was higher. So the insecticides here was linked to a higher level of viruses. So they conclude that the honeybee immunosuppression made by neonicotinoids was true for clothianidin and imidacloprid, and that explains why honeybees are more sensitive to viruses when exposed to these chemicals. There is another problem affecting bees. It is varroa. You know that by heart. In this publication made in Canada, they shown that in presence of a treatment with imidacloprid, it was on corn, the level of varroa in exactly the same conditions was higher when the crop were treated with imidacloprid as compared when the crop was not treated with imidacloprid. This is this graph. With imidacloprid, you have the red data, and without imidacloprid, we have the blue data. And they concluded that the presence of imidacloprid was linked, clearly linked, to a higher level of varroa. So you have some information about the interactions between the insecticides and viruses, as well as the number of varroa. So I can give you the conclusion. The conclusion is known from 1916. There is a lot of causes affecting honeybee health, or bees in general. And among these causes, there is monofloral resources, of course, pathogen and parasites, of course. But neonicotinoids in particular, as well as fungicides and pyrethroids, can affect the bee health. And there is a synergy between fungicide, which makes the insecticide more toxic, than the neonicotinoids making the pathogens and the parasites more affecting more honeybees, and all this is working together. So what is the solution? The solution is to fight parasites and pathogens, of course. Is a diversity in food for bees, of course, but it is also in reducing all these chemicals in the environment of bees. And what is true for honeybees is true for bumblebees, wild bees, for all bees, in fact. Now, okay, I gave you some information about bees. But I want to go further. And what were the hypotheses of exposure and toxicity for biodiversity? Because you will see that there is some impacts. So we made a huge study. It was in 2014, then in 2017. We made a huge study to understand all the data concerning this class of pesticides. It was more than 1,900 publications which were analyzed. And we published that through scientific papers. You have all the scientific papers here and all the scientific papers here in 3 books. And with all this information, which I will summarize, governments take decisions. You have to know that it was a sum of, well, we were a group of more than 30 scientists around the world working together without any financial support, just volunteers, independent from companies, of course, but also independent from all beekeepers, NGOs. We decided to work on this subject because it was a subject very important for biodiversity. And what did we find? We found, thank you. And what did we find? We found first that neonicotinoids, when applied as seed dressing, they were present in the soil. And you have a study in France here showing that the highest level of pesticide found in the soil concern imidacloprid here. And of course, being present in the soil, all the invertebrates that are present in the soil are exposed to this pesticide. And in this study, they find that there was a high risk of chronic toxicity. Chronic means several days. To earthworm for 46% of sample, which were in treated winter cereal, okay, in field treated, but also in non-treated habitats, because the chemicals is moving from the treated field to untreated areas. So I put the translation for you in German, and this was very clear. I can take another example. Now you are going in estuaries. And this study demonstrates that even these species are exposed to neonicotinoids. I will explain that. If you treat a field, the chemical is soluble in water, it goes in rivers, then to estuaries, and oysters are exposed. And this is a demonstration that this neonicotinoid insecticide expose oyster and at itself can have an effect on the oyster earth. Okay? So you will find the insecticide from the field to estuaries. And it has effect on the health of oysters. I go quickly. Now I take another example, which was made in Japan. They treated fields in Japan, and all these fields was up there to a lake, a big lake. And in about 20 years of treatment, they found that first, the zooplankton was affected, and there is a decrease in zooplankton from 1993, which coincided with a more than 80% decrease in zooplankton. Okay? And this was accompanied by a decrease of the smelt harvest from 240 tons to 22 tons, a factor of 10. If you decrease the zooplankton, you decrease the food of these fishes, and then there is less fishes. So you have an example here, which I call a cascade effect. You treat fields, the chemical goes in the lake, it kills zooplankton, then you have effect on fishes. This is demonstration which were very interesting. I can take another example with birds. This is a study made in Holland. And in this study, they analyzed water, surface water, and they correlate the contamination of surface water with the decrease of birds. I don't want to go into detail because there was a lot of species of birds studied. Some were not very affected by imidacloprid, but some were highly affected by the toxicant. And in Holland, they saw very sharp decrease of population of some birds, and the result is that at imidacloprid concentration of more than 20 nanograms per liter, this is very, very small. This is not 20 nanograms per gram. This is 20 nanograms per liter. A liter of water weighs 1 kilogram. So it means 1,000 times less than the amount killing bees. Okay? So at this concentration, which is very common, in fact, in all rivers, bird population tended to decline by a mean of 3.1% on average annually, every year. Every year. We have a problem with birds as well. So this publication made a lot of noise, and it participated to the decisions that have been taken by governments. And because we don't have so much time, I want to summarize. And we summarize in this figure, which is pretty complicated, but just have a look to the first line and the red marks. In fact, imidacloprid and neonicotinoids in general, they are not only affecting terrestrial invertebrates such as bees or pollinators, they are also affecting directly or indirectly some other species, which are very important for ecosystem. Pollinators, of course, which are exposed by pollen and nectar mainly, but also by the contamination of soil. Other terrestrial invertebrates here, by pollinators exposed by nectar and pollen, but also by contamination of air. During the sowing process with the sowing machines, there is a huge huge contamination of hair around the sewing machine. Other terrestrial invertebrates are exposed by plants, of course, pollen nectar, but also by contamination of soil. And what was new is that the situation was the same for aquatic invertebrates, as you have seen. And the danger was the same thing, in fact. And you have to remind that aquatic invertebrates, they are the basis of biodiversity on the Earth. Without aquatic invertebrates, there is no life. Most of the planet is composed by oceans and seas. We also find some information about amphibians, fishes, birds, which are mainly affected by indirect effects, because there is less prey, they have less food. You have to know that all birds, for instance, they need insects to feed the chicks. Whatever the bird will be eating later, seeds or grains, or if these birds will be insectivorous birds. At the very beginning of their life, chicks, they need insects to feed. Okay? No insect, no chicks. You all know this picture of the mother bird or the father bird giving an earthworm to the chicks. This is life of birds. Without insect, no birds. And a special mention here for mammals, because I said in my title that I am going to speak about our Earth. Let's go to our Earth. First, there is a global study here around the world showing about pesticides in general, that across countries, pesticide use in this alligated health food is extensive, with up to 97% of food items containing residues of pesticides. Wow! Difficult to avoid eating pesticides at lunch, at dinner, at breakfast. And up to 42% posing dietary risk to consumers, means levels of these pesticides above the maximum residue limit that is given by regulators. Regulators, they give a maximum residue limit above which the food is not good for your health, and under which you can eat safely. But you have to know that 42% of this food is for the problem, above this limit. Of course, in Europe, this ratio is better than in South Asia. But when you import some food from South Asia, mango, coconuts, pineapple, whatever you want, you should remember that they are often treated with high amount of pesticides and probably are above the maximum residue limit, which is safe for your health. That's why I question this. 5 fruits or vegetables a day, okay, but safe vegetables and fruits. This is a situation of exposure for us. Now, let's go to the effects. You have a publication here showing some effects related to neonicotinoids and especially imidacloprid. For general population, studies reported association between chronic neonicotinoid exposure, chronic, over days, over months, over years, and adverse developmental or neurological outcomes. This is mainly neurodevelopment of babies. Tetralogy of Fallot, which is cardiac disease, and you have a baby here born with this disease, and the baby needs a surgery. You can see here the surgery trace, because the heart is not functioning properly. Anencephaly. Anencephaly is very bad for babies because there is a lack of a part of the brain. And this is not a fake picture here. This baby, he was called Jackson. He was American. He died at 5 years old. And you can see the skull here is not normal. There is a part of the brain which is not present. Autism spectrum disorders. The use of neonicotinoids was linked with autism disorder. It could be light disorders, such as a difficulty for kids to concentrate. It could be severe autism, memory losses, and finger tremors. You know, this is a neurotoxicant. It's not surprising that the effects on our health are neurological. But this means also that this neurotoxicant not only acts on insects' brain, and of course not only act on pest insect brains, okay? It works for every living system. Let's go further. This is a Japanese study because in Japan you have to know that they use more amounts of neonicotinoids than in Europe. 5 times higher amounts. And it is in Japan that they have the most problematic situation. In fact, during the registration process, it was said that it was impossible for this molecule to reach the endocrine system and also to reach fetus. Okay? But we made a very simple experiment. When babies were just born, you know, babies when they at birth, they do 2 things. They cry and they take a lick. We collect the urine of these just born babies and we analyze the urine. And in the urine, there were neonicotinoids, showing that exposure of fetus was rare. And we made a further study examining the size of the skull, the weight of the babies, and we found that babies born after 9 months, the correct time, which have a very low weight, they have more neonicotinoids than others. That's why I put this picture here. So these babies were born after the normal time, 9 months, but very low weight. Very low weight means about 1 kilogram, 50. So the conclusion is here. Newborn babies have been exposed during pregnancy. Another issue, which is really problematic, we find a link between neonicotinoids and trouble for I don't remember, for kidney disease, okay? Kidney diseases, they are very well known, but there is a part of kidney disease which is unknown. We don't know the origin. That's why we call chronic kidney disease of unknown origin. And going to Sri Lanka, somewhere here, we found that the level of neonicotinoids was linked with the occurrence of this unknown chronic kidney diseases. And you have to know that this is a very important disease because it kills billions of people. You have a map here showing where the kidney diseases are acting the more. And in this publication, we also list all the symptoms linked to neonicotinoid intoxication for humans. I don't want to go into details, but depending if the intoxication was acute or chronic, you have different symptoms here. This is very helpful for doctors. And what we find is that there is a metabolite, a derivative of the neonicotinoid, which is systematically present in urine of these people having chronic kidney disease of unknown origin. So now we can conclude that we have a clue to explain this unknown origin. Another hypothesis which was done is that neonicotinoids, they are not going in our central nervous system. That's why these insecticides were permitted, in fact. But this publication, made by Swiss people, demonstrates the opposite. In fact, they analyzed the cerebrospinal fluid of some kids, and they found only a small amount of kids, of course, and they found that in all samples there was at least one neonicotinoid, and that 13% samples has this N-desmethylacetamiprid, which is one neonicotinoid among the family. So remember that the two main hypotheses for registration were no exposition of fetuses and no action on our central nervous system. And in fact, these two hypotheses were false. So now we have some data about these pesticides and what has been done about regulations. So I am going to present French laws, and you will see that in Germany they take decision too. So in 2016, the French government, the French deputies, in fact, it was voted at the National Assembly, decided a total ban of neonicotinoids to protect bees, to protect biodiversity, and to protect our health. And this decision was a little bit complicated because the decision was taken in 2016, applying in 2018, just for farmers to make the transition. So you have the decision here, and I translated the decision by the French Parliament. But what happened? It was funny, some kind of funny. Neonicotinoids were banned, but companies, they decided to sell other molecules very close to neonicotinoids, but not called neonicotinoids. It was flupyradifuron and sulfoxaflor. So they tried to circumvent the French law. So the French parliamentaries decided to make another law, more restrictive, saying that in the first law, the word neonicotinoid should be replaced by all the molecules having the same mode of action, making sulfoxaflor and flupyradifurone banned. And this decision was taken, I don't remember, probably in 2000, I don't see, but just later. Okay? So, in France, all neonicotinoids and all molecules having the same mode of action are banned. Thank you. Now, let's go to the European level. At the European level, in 2013, they made the first decision, banning one neonicotinoid, then another, then another, then another. And finally, in 2000, this year, they decided to ban all neonicotinoids except one. This one, acetamiprid, which is mainly used for fruit trees. And if you remember well, it is this one making this metabolite, and it is also one of this one, DMAP, dimethylacetamiprid. Okay, so this is a kind of surprising because at the European level they wanted to protect bees and biodiversity, but they did not ban the one which is the most problematic for human health. It will come probably, but this is interesting to see that. So actually, at this moment, all these neonicotinoids are banned, except under greenhouses. And in fact, you have to remember that there was no significant yield reduction for crops in Europe after 2013. Companies and farmers said, wow, we are going to die because we will have no food. This is a catastrophic decision, etc., etc., etc. And in fact, there was no yield decrease for farmers. So the situation in France, which I can summarize, is partial ban from 1999 to 2010, and total ban in 2018. In Italy, you have a decision here. In Germany, the European moratorium of 2013 was applied. Additional ban was pronounced in 2015, and the Euro moratorium of 2019 applied also. Okay? This moratorium said that imidacloprid, tiavetoxam, clotanide was banned. Okay, so little by little of this molecule disappeared of our environment. You have the situation in Philippines and in Japan. I want to cite the situation in Canada. Mostly bans were pronounced in cities, and they decided an 80% reduction in Ontario of the use of neonicotinoids. This is not a total ban. This is a reduction of 80%. And a similar decision has been taken for Quebec. And in the USA, it was impossible to ban neonicotinoids because farmers were so strong and they defended these insecticides. But bans were pronounced in cities and in some regions, for instance, Maryland, in all Maryland, which is a small state, in 2016, and new regulation where we wait for new regulation in this year, okay? But nothing is really done in the US. Now, I still have time, yes. In fact, when you ban some insecticides, farmers, I said, well, but what to do without them? We need them. So we decided to work a little bit on alternatives. My friend Lorenzo Furlan, an Italian agronomist, will speak this afternoon about alternatives. But I just want to give you some information, short information about that. First, looking to France, neonicotinoids were used on 2,968 crops, almost everywhere. And from these 2,968 uses, a special commission from the French government, I was not in this commission, but anyway, looked if it was really necessary to use neonicotinoids or not. And they found that alternatives were possible for 96% of this use. So, when farmers said, we need neonicotinoids, the government responded, no. In 90–60% case, you can do without these highly toxic chemicals. And more important, to my point of view, is that in 78% of these cases, at least one non-chemical alternative method could replace neonicotinoid. It's not a question to replace one chemical by another. It is possible to replace chemicals by alternatives which are not chemical, just using integrated pest management. So this was very important. But you can see that this is not 100% here. And the trouble came from farmers who cultivate sugar beet. And in fact, they claim that it was impossible to produce sugar beet, and especially sugar, without neonicotinoids. So you have sugar beet here, you have aphids of sugar beet, making the sugar beet getting yellow, and the amount of sugar was decreasing. So they claim so high, they shout so much that the French government decided of the reintroduction of neonicotinoids only for sugar beet production. And this was in 2020, 2021, and 2022. It was 450,000 hectares of sugar beet which has been treated these 3 years in France. But in fact, when we look to the yield production of sugar beet across Europe, there was no huge decrease in 2020. The production never ceased to increase, in fact. It was a false problem. And the French government decided to see if there was for sugar beet, especially alternatives. And in fact, the conclusion is written here. 4 solutions at short term have been identified for the culture for sugar beet crop production, without neonicotinoids, of course, and 18 other solutions should be developed to replace neonicotinoids, especially for sugar beet. So the conclusion is that it is possible to produce sugar beet without neonicotinoids. Okay? Even in this case, there is alternatives. But in fact, the decision of the French government to give an exemption for sugar beet was illegal, just illegal. And this is Belgium people who asked to the European Commission if it was legal or not. They made that injustice. And there is a translation here of this sentence. No exemption is possible if the European Commission formally bans a pesticide. There is no question of exemption. When it is banned, it is banned. So there is a decision here, making my talk finished, and I can give just the conclusions for you. The main conclusions. Neonicotinoids. 1, they are toxic to bee. It is sure. They have effect on bee health. They are toxic for biodiversity. They are toxic for humans, and they are not essential for crop production. Let's go to more global view about pesticides. This is just some information for you to think about. Pesticides. Clearly, there is inappropriate regulation about pesticides. And I gave you one example saying that the tests on pesticides for bees are done on 1 day or 2 days. And by chronic exposure, we know that after 8 days, we can have mortality or health effect for bees. Another point is that, speaking about pesticides, there is a general pollution everywhere. In air, in soil, in water, in the food. And to protect our life, our kids, our health, we should take care about this pollution because there is no one product, but a cocktail of products. And we know nothing about the interaction between molecules. We just know that fungicides and insecticides act synergistically. We are sure of that. But we don't know about the dozen of molecules present in our environment. What do they do? Another point of reflection is late laws and their exemption. We should take care about that. Laws are taken after the problem occurs. It would be better to take decision before the problem. We are not chimpanzees or monkeys on which we test. Tests should be done before registration and not after. And this last sentence, this represents private benefits and the risk for health, they are concerning all the public. We should reflect about that. And now the last but not least conclusion about bees and pollinators. This represents our food, our food. Without bees and without pollinators, mainly you will have just rice and wheat to eat. No chocolate, no strawberry, no fruits, no vegetables. And the biodiversity, it is our ecosystem. There is just one ecosystem on Earth, and everything is linked. And I just want to introduce this concept. We have just one planet, and there is a new concept I will speak about this afternoon. It is called One Earth. There is just one Earth. This is not the Earth of bees, the Earth of cows, the Earth of people. This is just one Earth. When there is a problem of Earth for bees, one day or another, it will become a problem for us. What kills the bees has an effect on everybody. Remember that. So, I would like to finish to present this funny picture about the threats on humanity. We have COVID, we have the recession, we have the climate change, which is very frightening, and more important is the biodiversity collapse. And governments and some people say just wash your hand and everything really going well. Don't believe that. Act. We should act against this biodiversity collapse. I thank you for your attention. If you want to go further, just have a look to this document from Arte Tema. You have the link here on YouTube. It's a 1 hour and a half document, very, very interesting on how companies have killed insects. This is the title. So you can go on YouTube to see that. And of course, I would like to thank all my collaborators in France, in the world. I would like to thank the beekeepers for their support and determination in this process. And of course, thank you again for your attention.
Ja, Jean-Marc, 48 Stunden.
Wait a minute.
48 Stunden Test.
How does it work?
Here, let's switch it on. And number 1, isn't it?
Yes.
Is it English?
It's okay, thank you.
48.
Thank you for the translators.
Natürlich.
Ja, auch danke an die Dolmetscher. Danke.
48 Stunden Test sind die, glaube ich, auf 72 Stunden jetzt erhöht worden. Das ist eine Unerhörtheit. Es gibt auch OECD-Richtlinien, nach denen Toxizitätsmessungen gemacht werden müssen. Wie kann das sein, dass die Industrie es geschafft hat, mit so einem Trick diese Mittel zuzulassen, zur Zulassung zu bringen?
In 2013, a group of experts working for the EFSA, the European Commission for Pesticides, for registration of pesticides, decided to make the test properly. And they wrote a new directive for tests. And this new directive was very protective for bees. And they wanted tests on a longer time, 1 week, at least 1 week, and even 2 weeks. But this directive has never been adopted by the states in Europe. Because the states, they vote for a new directive, which was proposed by EFSA, but the text was not adopted. 1 time, 2 times, 3 times, 4 times, 10 times. Every year the text was proposed, and every year the member state rejected the test. Most of the countries did not want the new regulation protecting bees. And this day, the text is not voted. Every year it is rejected. So these new tests on a longer time for toxicities of bees are not valid at this moment. They are proposed by EFSA, but they were not adopted by the governments. Probably the people registering the molecule will take better care to the data presented by companies when they want to register a product. But anyway, the tests are not mandatory at this moment. The longer test.
Und das müssen die nationalen.
So they have to be approved by the national governments, not by the Commission.
The active molecules are approved at the European level. So imidacloprid, for instance, in this case, was approved by Europe. And after that, each formulation with the additive substance and so on, are approved by each country. So you can have a general acceptation of a molecule at the European level, and after, in Germany, in France, they discuss about the formulation, and the authorities, they decide to take or not the formulation for their country. They can be more restrictive than Europe, but they cannot be more permissive than Europe. If an active substance is not registered at the European level, it cannot be registered as a formulation in a country. But if Europe says, okay, each country can say, I take this formulation, but not this one, etc., etc., etc.
So, das nächste Mal dem Minister mitteilen. Ja. Wobei, ich hatte ja letzte Woche Gelegenheit, vor unserem Landwirtschaftsminister eine kurze Rede zu halten, wo ich ihn auch auf Glyphosat angesprochen habe und die Verhinderung der Ablehnung der Verlängerung des Vorschlags der EU-Kommission, also des Vorschlags geht ja gar nicht auf die Partei zurück, die den Landwirtschaftsminister stellt, sondern auf die FDP. Das Verkehrsministerium und das Forschungsministerium, das beides FDP geführt ist, hat Einspruch eingelegt, sodass Deutschland sich enthalten musste, entgegen dem Koalitionsvertrag. Also auch Deutschland will Pestizide und Neonicotinoide. Wir produzieren sie auch. Das ist also das eine. Danke für die Klarstellung. Und unsere Bienen bekommen ja Zucker. Ist denn in dem nachher raffinierten Zucker, sind denn da noch Neonicotinoide nachweisbar und wenn ja, in welcher Höhe?
I have a good news for you. In fact, even the sugar is coming from sugar beet treated with insecticides. There is no insecticide in the sugar that is sold in everywhere, and especially there is no insecticide in the sugar from sugar beet that beekeepers give to the bees. We check on some sugar given to the bees, and the way the sugar is produced makes the chemicals, the chemicals they are not transferred in sugar, because this is a crystallization process, and you only there is only sugar in crystals and not the chemical. This is a chance.
Okay. Da haben wir nochmal Glück gehabt. Wer hat...
Yes, we've been lucky here. Now, who stopped the French government voting against the extension of glyphosate use in France?
Glyphosate. This is a big, big problem for everywhere, everybody everywhere. In fact, glyphosate, there is two kinds of approach. The regulatory approach, which looks only at some studies furnished by companies, and the scientific approach, which looks on all data furnished by companies and independent data made by scientists over the world. And depending on which data you look, you don't have the same conclusion. In one case, regulators, they conclude there is no problem, just looking to data furnished by companies, and in the other case, they conclude there is a big problem. I don't want to pronounce about glyphosate because I am not a big specialist of glyphosate, but you should know that yesterday, just yesterday, there is a huge study, international study, another one made by independent scientists which concludes there is a problem, a big problem. I can give you a reference if you want. It's not published, but there is an announcement, an official announcement. And about glyphosate, the problem is here. Depending on where you look, you don't have the same conclusion. And if you want just to look to data from companies, even me, I will conclude there is no problem, but probably these studies are flawed, just flawed. And the problem of glyphosate came from incomplete data from companies, data looking only on small effects, forgetting other effects, especially cancer and so on. Data on the molecule itself and not on formulations. And you have to know that on formulations you have some other substance which are added. And this substance makes the chemical more toxic, sometimes 1,000 times more toxic than the chemical alone. You should know that. All these formulations are not the same everywhere. So you have some countries where they use glyphosate very often and with high doses, and some countries which are more restrictive. In France, for instance, they decided to ban, I would say, 1/3 of the formulations of glyphosate because there were problems on that. So little by little, because the European Commission do not ban glyphosate itself, France decided to ban some formulation. Little by little, they will probably ban all glyphosate formulations. So no problem. What can be done at the European level can be done at the state level. So depending on your Minister of Agriculture, you can push a little bit the Minister of Agriculture to take decision. It's possible to restrict in each country.
Ich werde es ihm sagen. So, gibt es ein paar Wortmeldungen, Wünsche?
Wenn der Druck auf die öffentlichen Entscheider möglichst groß sein soll, welchen Beitrag können wir Imker vielleicht ausüben, um für Transparenz und Aufklärung zu sorgen und den Druck zu erhöhen? Ich möchte erinnern an die Aurelia-Studie im letzten Jahr, wo Rapshonige in Deutschland nach Neonicotinoiden untersucht wurden. Da haben 150 Imker leider nur mitgemacht, also weniger wie hier im Raum. Von 150.000 wäre hier vielleicht mehr Druck möglich, wenn mehr mitmachen, weil man hat schließlich festgestellt, dass 4% der Rapshonige Thiacloprid beinhaltet haben. Und das ist ja schon längere Zeit verboten in der EU. Gibt es in Frankreich solche Untersuchungen von Honig? Würde das helfen, mehr Druck auf die Öffentlichkeit und indirekt auf die Politik auszuüben?
First, I would like to respond that all these decisions that have been taken by France and by Europe, they are the consequence of associations, including beekeepers. Beekeepers played a key role in France and in Europe to defend bees and biodiversity. And it was efficient. They make noise, they make some explanation to politicians, to regulators, they investigate, they took the information from scientists, they invited scientists like me in such meetings, they took the information and they spread out the information to everybody. And being together, beekeepers, they represented a big force, a big strength to make these things to change. And it was efficient in France, it was efficient in Italy, I am sure it could be efficient in Germany as well. And I would like to underline the key role of beekeepers in this subject, because I think you, beekeepers, are the first victims of the excessive use of pesticides, and especially insecticides in crop production. But you are representative of the safeguard of biodiversity. And with this argument based on scientific data, I insist on this, you should have the base of the science. Then you can go to communicate with farmers, with regulators, with politicians to say, well, when you save the bee, you save the health and the global health of everybody. And this is a big argument, in fact. Who wants to kill babies? No one. So with such argument and being together, you will have probably the strength to change the things. And this will probably be the conclusion of my second talk this afternoon. And we have tools for that. Just being together and to be persuasive.
Zu können.
Sicherlich gibt es Ängste in der Imkerschaft, den Honig sozusagen als Indikator zu nehmen, weil man sonst vielleicht meint, man bekommt wieder eine schlechte Presse, aber in meinen Augen ist es unerlässlich, den Druck zu machen. Im Ausland wird er auch gemacht. Das machen nicht alle im Ausland. Da ist es auch nur ein Teil der Imkerschaft, die mitmacht. Aber ich denke, auch wir hier müssen diesen Weg gehen, weil uns hilft niemand in der Politik. Wir müssen den Druck machen. Und wenn wir die Bundesebene kritisieren, dann sollten wir schon auch den Landwirtschaftsminister adressieren, aber wir sollten auch die FDP adressieren, denn die FDP verhindert im Moment die Veränderungen. Und auch ich werde in Zukunft die Adresse der FDP-Bundestagsfraktion bei mir in die Adressliste mit aufnehmen. Wir dürfen jetzt nicht sozusagen den prügeln, der es eigentlich machen möchte, und es wird verhindert durch eine Partei. Das ist nun mal so. Bernhard, natürlich.
Hello. Are you aware and are you looking as a scientist into the new technology modified mRNA? And because it's a topic and a new topic in plant protection, is this a new danger we should look at?
I am not very competent in the change in genetics. Well, I won't say anything about this, but I will respond to your question just before. When beekeepers analyze their honey, for instance, it has been done all over the world. And there is a publication made by Swiss people showing that almost all honey in the world is contaminated with neonicotinoids. And beekeepers, they can say, oh, my God, my honey is contaminated, this is a problem. I won't sell any more honey to the public. But in fact not, it was very low doses affecting the health of bees, but not affecting, of course, our health. This was so tiny. What I want to say is that don't be afraid to accept that some chemicals could be present in honey. This is bad for bees, and of course this is not bad for our health. We are bigger, you know, especially, well, this is not the same weight between a bee, 0.1 gram, and me, more than 80 kilograms. So don't be afraid about that. People will understand that honey could be contaminated by pesticides, and this represents a threat on bees, but not a threat on our health, okay? So this is just to give an answer. And now to go back to the question of genetically modified species. Could be plants, could be bees, could be whatever you want.
Noch nicht jetzt.
Is it really a good question? Do we have to invent technology again and again to solve our problem? This afternoon, I will show through alternatives or through the choice of less toxic pesticides that we could do with what we have already. And the way to think is to use nature. On a picture this afternoon, I will show you some aphids on a plant and a ladybug. And instead of putting an insecticide killing the aphids and the ladybug, maybe we could use the ladybug, which eats about 100 aphids a day, to protect the plants. So instead of going further and further in technology, which probably will represent a problem later, just do with nature and not against nature. Perfect in time.
Gut.
Also, das war jetzt, würde ich sagen, der Teil heute Vormittag. Und heute Nachmittag kommt er ja nochmal dran. Wir werden die Reihenfolge tauschen. Der Herr Lorenzo Furlans Vater ist gestern verunglückt, sodass er heute herfliegen musste, nur da sein kann, 2-3 Stunden und dann wieder heim muss. Und so tauschen wir nachher die Reihenfolge. Gell? Also, ja, dann machen wir Mittagspause jetzt.